Hey everyone, today we're going to pull back the curtain on a piece of Java code you've probably typed 100 times without even thinking about it. We're talking about constructors, and trust me, by the end of this, you'll see that mastering them is your key to building way more intentional and powerful applications.
So, if you've ever written any Java at all, this line should look super familiar, right? It's how we create a new object from a class. It feels automatic, almost like a little bit of magic.
But let's actually stop and think about this for a second. We know the new keyword goes out and reserves the memory for our object. But what's the deal with that human part? It kind of looks like a method call. But is it? It's not just there for looks. It's the actual command that builds the object.
To really get what's going on, we have to look at something that Java does for us, kind of behind the scenes. It gives us this invisible blueprint to help us out, and that's called the default constructor.
Okay, so here's the magic trick revealed. Even if your human class file is completely empty, that line of code we just saw, it still works. How? Well, it's because the Java compiler is basically your helpful assistant. If it looks at your class and sees you haven't made a constructor, it just quietly adds one for you, totally free of charge.
So what does this free invisible constructor look like? Well, it's the most basic one you can imagine. It has no parameters, that's why we have the empty parentheses. Its body is completely empty. Its one and only job is to exist, so the new keyword has something to call to let your object be created.
Okay, but that freebie constructor creates a new problem for us. A totally blank human object isn't all that useful, is it? We probably want to create a human that has a name and an age right from the very beginning. And to do that, we need to stop letting Java drive and take the wheel ourselves. And this is really the core idea. What if we want to create Naveen, who is 18 years old, in one single clean step? Now, sure, you could create a blank human object and then call setter methods to set the name and age, but that's 2 or 3 lines of code. Good programming is all about being efficient and clear, and we can definitely do better. And here is exactly how we do it. On the right, you can see we've written our own custom constructor. The big difference? Look inside the parentheses. We are now telling Java, hey, to create a human object, you must give me an integer and a string. This is what we call a parameterized constructor. So let's trace the data flow here, step by step. First, when we call new human, we pass in our values, 18 and Naveen. Second, those values get caught by the parameters in our constructor, a and n. And finally, inside the constructor, we take those values from the parameters and assign them to the object's own instance variables, age and name. It's a direct pipeline.
And here's the payoff. You can see the difference so clearly. On top, using a default constructor might give us some generic John. But on the bottom, using our new parameterized constructor, we get exactly the object we wanted, Naveen, age 18. This is what taking control of object creation is all about.
All right, now we have to talk about something that trips up almost every single person when they're first learning Java. It's a really common trap you can fall into right after you write your first custom constructor. So let's solve this little mystery.
Okay, so here's the scene. You've just written your awesome new parameterized constructor. It takes an age, it takes a name, you're feeling pretty good about it. Then, a little later in your code, you try to create just a simple default human object, using the empty parentheses, just like we did at the very beginning.
And bam! Your code doesn't compile. The compiler throws an error that looks something like this. It's basically yelling at you, hey, I can't find a constructor for human that takes 0 arguments. And you're sitting there thinking, wait a minute, didn't Java give me one of those for free? Where did it go? And here it is. This is the solution to the mystery, and it is the single most important rule you need to remember about this topic. The moment, the very second, you write any constructor of your own, Java's free, invisible, default constructor vanishes. It's gone. Java basically says, oh, you're defining the rules for how to build this object now? Okay, I'm out. You're in charge. But what if you want both? What if you want the power to create a fully custom object, but you also want the option to create a simple default one? Well, the good news is you absolutely can, and this is where a really cool concept called Constructor Overloading comes into play.
Now, constructor overloading sounds kind of fancy, but the idea is actually super simple. It just means you can have as many constructors in one class as you want, as long as they each have a different signature. And a signature is just the list of parameters. So a constructor that takes 1 int is different from one that takes 2 ints, which is different from one that takes 1 string.
So by using overloading, we can make our human class way more flexible. We can write our own public human constructor with no arguments for a default human. Then we can add another one that maybe just takes a name.
And of course, we can keep the one we wrote that takes both an age and a name. Now our single class has multiple blueprints for creating different kinds of human objects.
Okay, let's wrap this all up with a quick review. This is the stuff you really want to have locked in, especially if you're studying for an exam or prepping for a technical interview.
Honestly, this table is pretty much the whole story. The default constructor has no parameters, makes a standard object, and is given to you by Java, but only if you don't write any others. The parameterized constructor has one or more parameters, creates a custom object, and you always have to write it yourself. It's what gives you control. That's the core of it right there.
So the next time you type new in your code, you'll know exactly what's happening under the hood. You're not just making an object, you are literally controlling how it's born. So the question is, how are you going to use that power to make your code cleaner, more flexible, and even more powerful? Thanks for watching.